So imagine a customer's just ordered a fire poker. You need 12mm square, but your idiot boss hasn't ordered any lately. You do have some short lengths on your neat scrap pile though, so what are you going to do? Scarf weld two bits together, of course. Make sure your fire is tall before you're ready to weld, as putting fresh fuel on cools it down. Tall fire is also hotter and raises the neutral layer. See my fire video to better understand this. The first task is upsetting, not you, the metal. Heat the end of your bar to a bright heat, the hotter the better. You want the first heat to be about an inch long, so quench off anything further back than that. Stand the metal upright and start upsetting with heavy blows to the top of the bar. Hit it hard, but it won't hit you back. Upsetting is pushing the metal back on itself to make the hot end fatter as it converts length into thickness. You need the extra thickness to prevent two things. The first is wastage. The longer a piece of metal is held at a high temperature, the more of it you lose through oxidization. The second is overforging. You need to forge the scarf joint heavily to ensure a good weld. If the parent bar isn't thick enough, you'll end up thinning it below its original section. I generally upset in two heats. The first heat is short and gives it the main thickness I want. The second heat is longer so as to upset further back along the bar. You'll also do the second heat at an angle in order to create a short blunt taper. This will be the turn of the scarf. To finish the scarf, I create a short set down over the edge. The set down locks the two scarves together. The set down needs to be as short as possible, as this will be the length of the weld. The longer it is, the harder it will be to weld it completely. When creating the set down, I hit the metal at an angle of about 80 degrees. This creates a bend below the scarf which helps the two pieces fit together. Repeat the whole process for the second bar. You can now see the two scarves ready to be welded. Notice how they fit together with the set downs. And you can also see the bend behind the scarf. The scarf must start with a taper. This helps the contacting surfaces weld together because the taper doesn't have the volume to punch through the opposing piece. If the scarf started with a flat end, it would simply shear through the second piece without welding. A quick demonstration to illustrate what I'm talking about. These two pieces have been welded without a scarf. After a quick clean-up, the damage is clear and as predicted. The two straight ends have simply sheared through each other, causing a deep gore. A quick destructive test will show that it isn't purely a cosmetic problem, as the weld has no strength. To make sure that you don't try and forge weld with one of the scarves upside down, it can be useful to chalk on the top of each bar so you know which way to orientate them before you even pull them out of the fire. It's also useful to have a dry run or two so that you know the best position for everything and where your tools will be when you need them. Speed is critical. When you have the scarves in contact, drop your tongs. Don't try and find somewhere to put them, just drop them. Open your hand and let them fall. Notice how I hit at an angle just behind the crest of the scarf. That angle helps drive the two pieces together for the initial weld. When you start heating the pieces, you need a long heat on both. This is to stop the rest of the bar robbing the heat out of the scarf. If you have a short heat, then the metal will be too cold to weld before you even pick up your hammer. A quick demonstration. Using a deliberately short heat overall, but a welding heat on the toe of the scarf, something I see beginners doing quite often. Predictably, this fails. However, I have another point to make, so I take a second heat, but make an effort to weld it this time. How do you think this is going to come out? After a quick clean, the flaw is evident. Even though I took a second pass off camera to try and blend it in, the damage is already done and an irreversible shearing plane had been created, evidenced by the cold shot going through the metal. Let's take a brake test. This shows you why you need a long heat back from the scarf. So back to the main weld. Heat the two pieces of metal so that they're reaching the welding heat at the same time. If one heats up quicker than the other, swap their position in the fire. You'll need to quench off the toe of the scarf once or twice to prevent it from burning off whilst the rest of the scarf comes up to a welding heat. I couldn't film it with my camera, but you're looking for a bright white molten surface on the metal. Once they're ready, then weld. The first weld is just to tack the two together. Firm heavy blows are required. Just a few hits on the top and side of the scarf and then straight back into the fire. The second heat is to weld it together properly. You only have a few seconds to do this before the metal is too cold. By the second heat, the weld should be complete and invisible. However, I often take a third heat just to finish blending in before forging the area down to section. When forging down to section, I swap to a heavier hammer with a wider face, as this makes it easier to achieve a flat finish. I also give it a good scrub at this stage, as I aim to remove any burn, scale or clinker marks in the metal before forging it to section. Looking at it when it's finished, I find it hard to find where the scarf was, as it's pretty much invisible due to being done correctly. After cooling down the piece, I find evidence of the scarf on a corner, the smallest of nicks. Corners are the best place to find evidence of the scarf weld. So I suppose at this stage I'd better put my money where my mouth is and perform a destructive test on the weld in order to show how weak it is. By the way, you'll have noticed that I didn't use any flux for any of these welds. That's because there is simply no need to. I do use flux occasionally if I'm welding carbon steel or delicate elements, but for general use, meh.